left off, we were talking about the electrical conduction system of the heart, the pacemaker of the heart. What was that? Our SA node. Now, when we look at the structure, well, this electrical and this contractile activity of the heart, we're going to have cycles that are going to occur, and one cycle is going to be a contraction and a relaxation of the chambers of the heart. Now, when we say systole, systole is telling us it's contraction, diastole, relaxation. Because we're going to come back to those terms, I've written them up here so that we can remember. And it refers to either chamber, whether we're talking about the atria being in contraction or relaxation, or the ventricles being in contraction or relaxation. So as we look at these events that are going to take place, we generate what's known as a cardiac rhythm. Now, under normal conditions, we get that nice little loved up. We get that nice little boom, 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 boom that we think of with the heart beating. Normal rhythm is called sinus. The sinus rhythm, usually in a normal, healthy adult, 70 to 80 beats per minute. This is termed vagal tone. Everything that we've talked about up to this point that has dealt with the electricity of something, whether we've talked about the muscles or whether we've talked about the nervous system, everything had to keep tone. Do you happen to remember what tone was?
The ability of the arteries or muscle to contract and relax, but it's in relationship to pressures.
Now, when we talk muscle tone, once again, working off of electricity, because we've got all of these ions, tone was the ability of the muscle to be ready to move, to contract. With the nervous system, once again, talking about electricity, the moving of ions, and we needed to make sure those neurons would be ready to fire. So we always kept a little bit of a difference in the charges. Does that make sense? Across the membrane. Well, now with the heart, once again, we're dealing with those ions, okay? And vagal tone is the difference in those ions, making sure the heart's ready to beat. Does that make sense? And it's called vagal tone. Now, when we have something that is going to set the rate of the heartbeat other than the SA node, this is when we have something termed an ectopic focus. Have you ever heard of that? Ever heard of an ectopic focus? Okay, that's when, for example, if we have the AV node, because we know the SA node is the pacemaker, that fires, sends the electrical impulses across the atria, and fires to the AV node, which goes to the bundle of His, which moves into the Purkinje fibers. Are you following me? If you have something, maybe the AV node, that's going to be the pacemaker because something's wrong with the SA node, Well, that's an ectopic focus. Something that starts the beating of the heart, other than the SA node, is an ectopic focus. Now, the problem with that, when something other than the SA node is setting the pace of the heart is now incorrect. So if we have a situation where the SA node should be keeping us at roughly those 70 to 80 beats per minute, but we have to depend on another area of the heart to make it beat, that's not going to be the norm. We're going to find usually a much lower heartbeat. If the AV node becomes the area to start the pacemaking of the heart, usually the beats per minute drop down to about 40. What's the problem with that? Now, if we can't survive like that, what is it that's not making us survive? The pressure is the movement of the fluid, meaning getting it to the tissues of the body to deliver materials and pick up waste, is not good enough. Does that make sense? Now, if we have another area other than the AV node that will try to fire the beating of the heart, most likely that's going to be death. So that's why when people have abnormal rhythms of the heart, they go, if it's the SA node, they can go in and they can do the pacemaker. Now, the SA node, when we begin to have the electrical potential, all right, the electrical potential, do you guys remember let's do where this is positive, negative, negative, positive, got 0 here. Do you guys remember that chart? Okay. And remember, we have to operate on millivolts, because if we have anything higher than millivolts, well, that's a little too strong for the body. So, just like with muscle, where we had the depolarization and the repolarization, we had the same thing with the nervous system. Well, now we're going to have the same thing with the heart, because once again, electrical tissue. Okay? Now, the difference, we do not have a stable resting membrane potential. Why do you think maybe that's the case for the SA node? Everything else had a normal, stable, resting membrane potential. Why do you think it's different for the heart? Okay? It has to work 24/7, 365, 366 if it's a leap year. However, these cells will make sure that they recover and rest between each beat.
Yeah, short beats, really short beats.
But, believe it or not, longer than what you see with skeletal muscle. What? How in the world does this work? Now, because we have beat, 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 let's do 60, okay? Let's do 60 beats per minute, 1 beat per second, okay? Think about that now, 1 beat per second. In that 1 beat per second, it has to contract, relax, recover. That's hard to think about, isn't it? It's hard to think about. But we're going to start down here at -60. And what will happen is we'll begin to go up and up and up, and then we'll come back and we'll recover. Does everybody remember that? From muscle and nerve. No? Yeah. Part 1 professor didn't go over that? Oh man, this is very important. Okay? Because this is something that's going to lead you into understanding the EKG, which is extremely important to understand. Here's what happens. Because we operate on millivolts, we can't come up here and say we've got 60 volts. How much does a battery have? About 16 volts, right? A car battery, okay? Car battery. Y'all ever had to fool with one of them things? Okay, I jumped my first battery probably last winter, okay? Now, I've seen it done my entire life, okay? Now, I got my positives and my negatives hooked up, okay? Crank my car, got the other one, got to work on, get that one going, go to remove my jumper cables, okay? What my daddy didn't tell me, okay? Don't let those two ends touch if the other one's still hooked to the battery that's running, okay? I found that out the hard way, all right? So that's a lot of voltage, right? So we can't have that kind of voltage. So we have to start where we're negative, and then we're going to move towards positive. So, do you guys remember threshold? All right, like once you have those channels open up and sodium is rushing in, and we're changing the positive and the negative, okay, across the plasma membrane, we had to reach threshold to make those cells contract, right?
Yes.
I want everybody to tell me yes. Yes, okay? So, now we have to get to -40. Why are we going up? Why is our negative getting less? Because the positives are coming into the plasma membrane.
The positives coming after.
All right.
It already goes over the positive. So
Hold your thought. Hold your thought. Follow me right here, okay? My plasma membrane. I've got my little channels that have the gate, right? Inside my cell, I'm a little negative. Outside my cell, I've got bunches of positives, and those positives belong to what? Well, some potassium, but mostly sodium. Now, this gated channel right here, this gated channel it lets what flow through it when that gate opens? It lets my sodium move in and making this positive. Is everybody following me? So if this was -60, I'm letting positive in, so I'm changing my positive. I'm making it more positive. And that's why it's going to less negativity. Does that make sense? Okay? So, when we look at the heart, we're going to find that we have our sodiums, we've got potassiums, but we also got calcium. Calcium is very important to the functioning of the heart cells. So we've got these positives that are taking place, and as we go from negative to less negative, am I depolarizing my cell or repolarizing it? I am depolarizing my cell. And then, once I get to my threshold, what do you remember about threshold? Once we reach, once we reach threshold, what's going to happen is going to happen. You're not going to stop it. All or none principle. Think about that for the muscle. Think about that for the nervous system. Well, we got to make sure this is occurring with the heart, okay? I mean, how many of y'all kind of like your heart beating? Okay, so if we do that, reach threshold, the SA node fires. If the SA node fires, we now set off this chain of events that will occur and be our one cycle of heartbeat. All right, is everybody with me? Once we have that one cycle,